A 70 billion parameter AI model, the same scale used by serious research labs, fits on a consumer laptop because most of its numbers get quietly rounded down before you ever download it. That rounding is called quantization, and once you understand it, running AI locally stops feeling like magic and starts feeling like engineering. By the end of this, you'll have a large language model running entirely on your own machine. No internet connection required, no API key, no usage fees. You'll understand exactly why it fits and how to pick the right version for your hardware. You need a laptop or desktop with at least 8 GB of RAM, a terminal, and about 5 GB of free disk space. No GPU required. No prior AI experience assumed. Step 1. Understand what you're actually downloading. A 70B model has 70 billion numbers, called weights, that define its behavior. At full precision, each weight takes 4 bytes of storage. That's roughly 280 GB. Nobody's laptop holds that. Quantization is the process of reducing the precision of those numbers. Instead of storing a weight as a precise decimal, like 0.347821, you round it to something like 0.35 using fewer bits. A Q4 quantized model uses about 4 bits per weight instead of 32. That same 70B model now fits in around 40 GB. Go to Q4 View KNM, a common well-balanced format, and you're around 38 GB. Smaller models like Qwen7B at Q4 land under 5 GB. The model gets slightly less precise. In practice, for most tasks, you won't notice. Step 2. Install llama.cpp. Llama.cpp is a runtime that loads quantized models and runs inference, meaning it generates text directly on your CPU. Go to the llama.cpp GitHub page and download the latest release binary for your operating system. Unzip it. That's your engine. Step 3. Download a GGUF model file. GGUF is the file format llama.cpp uses. Go to Hugging Face, huggingface.co, and search for Qwen2.57b instruct GGUF. Find the Bartowski repository, which packages clean, reliable, quantized builds. Download the Q4GKM version. That suffix tells you the quantization method and size trade-off. Save it somewhere you'll remember. And if you want real, usable tech skills like this, Stack Future covers one every day. Step 4. Run the model, open your terminal, navigate to your llama.cpp folder. Run /llama.cli - model, then the full path to your GGUF file, --ctx size 2048 -- interactive. The CTX size flag sets how much conversation the model holds in memory at once. 2048 tokens is a solid starting point. It'll load, print some stats, and give you a prompt. Type, get a response, entirely local. Picking a model too large for your RAM is the most common problem. A rough rule, your GGUF file size needs to fit in RAM with about 2 GB to spare for the system. If your file is 6 GB and you have 8 GB of RAM, you're at the limit. The model will load slowly and your system will crawl. Go smaller, try a Q3KM, or pick a smaller base model. Confusing quantization levels trips people up. Q4 and Q5 are the sweet spot for most use cases. Q2 gets very small, but quality degrades noticeably. Q8 is nearly full quality, but nearly full size. When in doubt, Q4C4KM is the default recommendation for a reason. Downloading the wrong file format causes immediate errors. llama.cpp only reads GGUF files. If you download a model in safe tensors or PyTorch bin format, which is what you see on many Hugging Face pages, it will not work here. Always confirm the file ends in .guf before you start the download. You just ran a real language model locally, and you now know exactly why it fits. Quantization trades a small amount of numerical precision for a massive reduction in size. The one thing to remember, the Q4KM format is your starting point for almost every local LLM experiment. From here, the natural next step is building a local chat interface on top of this, or experimenting with different model families. Quantization isn't compression in the zip file sense. It's reducing numerical precision across billions of weights in a way that preserves most of the model's capability. That distinction matters because it explains both why it works and where its limits are. Coming up next, AWS RDS versus self-managed databases on EC2. What actually changes when you let AWS run your database instead of running it yourself? If this video saved you time or confusion, A-like helps the channel a lot. It genuinely makes a difference.